Now we will discuss about the types of the improper integrals. First type of the improper integral of a first kind. In the definite integral, a to b fx dx, if either a or b or both a and b are infinite, so that interval of integration is unbounded or infinite, but fx is bounded. Then the integral a to b fx dx is called integral of first kind. That means integral a to b fx dx, this type of integral is called or is said to be integral of a first kind when the limit, upper limit or lower limit or both the limit of the integral are infinite and function is bounded. Then this type of integral is first kind of integral of first kind. For example, the integral 1 to infinity 1 upon under root x dx. So upper limit of this integral is infinity, but lower limit of this integral is 1, so finite. And function 1 upon under root x, the value of this function at x equal to 1 or at x equal to infinity. So this function is bounded at x equal to 1 or x equal to infinity because of 1 upon infinity, that is 0. So 0 and 1 both are finite value. Second example, integral minus infinity to plus infinity e raised to the power 2x dx. Third example, minus infinity to plus infinity of dx over x square plus 2x plus 2. So these are the, in the first integral only upper limit is infinity. In the second integral both the limits are infinity, and third integral both the limits are infinity. So these are the examples of improper integral of first kind because their limit are infinite, that is unbounded, and function is bounded, that is finite. Second type of integral, improper integral of a second kind. So an integral a to b fx dx is said to be improper integral of second kind if the limit are finite and function fx is not finite, that is unbounded. So in this case, in the second type of integral, second kind of integral, both the limits, improper integral, both the limits of the improper integral, limits are finite and function is unbounded. In the first kind of integral, both the limits or one of the limit out of these two limits is infinite, or both limits are infinite but function is bounded. In the second type of integral, limits are finite but function is unbounded. Second type integral examples are integral 0 to 1 dx over x square, integral 1 to 2 dx over 2 minus x, integral 1 to 4 dx over x minus 1 x minus 4. The value of the function 1 upon x minus 1 x minus 2 x minus 4 at x equal to 4 and at x equal to 1. In both cases, value of the function is not defined. because of 1 upon x minus 1 into x minus 4 at x equal to 4 is infinitive. Again, the value of this function at x equal to 1, so value of this function at x equal to 1 is also infinitive. That means function is not defined. The third type of the integral, improper integral of third kind. An integral of the type a to b, integral a to b fx dx, if the interval of the integral is infinite, that is unbounded, as well as function is also unbounded. For example, integral 0 to infinity e raised to the power minus x upon under root x dx. In this integral, limits are infinite as well as function is also unbounded. So the given integral is an example of improper integral of the third kind. Now we can convert the improper integral as the limit of a proper integral. Case 1, when improper integral of a first kind, that is either a or b or both a and b are finite but function is bounded. So we define this type of integral, that means integral a to infinity fx dx equal to limit t tends to infinity integral a to t fx dx when t is greater than a, because of t is the upper limit of this integral and a is the lower limit, so upper limit is greater than lower limit. The improper integral a to infinity fx dx is said to be convergent. So this type of integral is convergent. We check this type of integral is convergent or divergent or oscillate. So improper integral a to infinity fx dx is said to be convergent if the limit on the right hand side exists finitely. If the value of this integral, this limit will be finite, so integral will be convergent, and value of this interval, value of this limit will be infinitive, that is plus infinitive, or minus infinitive, that is the integral is said to be divergent. Next type, if the limit of the interval if the limit of the integral minus infinity to b fx dx, so we can write this integral in terms of limit. So limit t tends to infinity integral t to b fx dx when t is less than b, because of t is the lower limit of this integral. Then the improper integral, this type of improper integral is said to be convergent if the limit of a right side is finite, then the integral is convergent, and the value of the limit of a right side is plus infinity or minus infinity, so integral will be divergent. Next type, integral minus infinity to plus infinity fx dx. So we can write this type of integral in terms of a limit. So first we break this limit minus infinity to c fx dx plus integral c to infinity plus infinity fx dx, where c lies between minus infinity to plus infinity. where c is the real number. Or integral minus infinity to plus infinity fx dx is, so we can convert this integral into this limit. Lower limit is minus infinity, so limit t1 tends to minus infinity of integral t1 to c fx dx plus we convert this integral, so limit upper limit is in this integral, upper limit is infinitive, so we can use the limit for infinitive for upper limit, so limit t2 tends to infinitive integral c2 t2 fx dx. So the improper integral minus infinity to plus infinity fx dx is said to be convergent if both the limits are exist finitely and independent to each other. Both the limits, that means these limits. Otherwise, improper integral is divergent.